Most messaging systems have a broker at their heart, a central server that receives, stores, and forwards every message that passes between your applications. It's the post office everyone mails through. That broker is powerful, but it's also a thing you have to run, install it, configure it, scale it, and keep it alive. When it goes down, the messaging for your whole system goes with it. ZeroMQ makes a defining choice. There is no broker at all. It isn't a server you run, it's a library you link into your own application, so the messaging intelligence lives inside each program. That's part of what the zero means, zero broker. With the smarts baked into each app, peers simply talk to each other directly. Nothing central sits in the middle storing and relaying their messages. But ZeroMQ gives you far more than a bare network socket. It works in whole message frames, not a byte stream, so you receive complete messages instead of a pile of bytes you must chop up yourself. Its real substance is patterns, pre-built socket types that each encode a whole shape of communication. Publish-subscribe, for instance, fans one message out to many listeners at once with no central server required. Push-pull builds a pipeline that spreads work across a pool of workers and collects the results, balancing the load automatically. Different shapes for different jobs, all from the same library. And request reply gives you the simplest shape of all. One side asks, the other answers in lockstep. Let's walk through how a brokerless library pulls all of this off. Slow motion. First, the world ZeroMQ is reacting to. In the classic setup, your app doesn't talk to anyone directly. It hands every message to a broker, and the broker takes responsibility for delivering it onward. ZeroMQ removes that middle server. Instead, you link its library into your program. All the queuing, framing, and routing logic that a broker used to provide now runs right inside your own process. So your app connects straight to another app and sends. There's no server between them to configure or keep alive. The two peers hold the connection themselves, and messages flow directly across it. The first thing you notice above a raw socket, ZeroMQ speaks in messages. You send a whole message and the other side receives that exact whole message, never a half message, never two glued together. It also handles the messy parts silently. ZeroMQ reconnects dropped links and queues outgoing messages in the background, so a peer can disappear and come back without your code writing a single line to cope. But the real substance is the patterns, socket types that each encode a communication shape. You pick the shape you need and the library handles the delivery logic behind it. Let's walk the key ones. Request reply is the simplest. A client asks, a server answers strictly in turn. Send a request, get exactly one reply, repeat. It's a direct conversation with no broker mediating between the two sides. Publish-subscribe flips the shape. A publisher fires a message out and moves on instantly. Crucially, it doesn't know or wait for its subscribers, it just broadcasts, fire and forget. Any number of subscribers can tune in, each filtering for the topics it cares about. One message fans out to all of them at once, and because the publisher never waits, a slow subscriber can't hold anyone up. Push-pull is a pipeline. One end pushes tasks out to a pool of workers, and ZeroMQ load balances them automatically, handing each task to whichever worker is free. Add more workers and the throughput just grows. The workers pull tasks, do the job, and their results can be collected the same way at the far end. It's a conveyor belt of work spread across as many hands as you care to plug in. For fully asynchronous versions, ZeroMQ offers dealer and router sockets, the same request-reply idea, but without the lockstep, so many requests and replies can be in flight at once. The patterns compose and layer. And here's the quiet elegance. The very same code works whether the transport is threads inside one process, processes on one machine, or peers across the network. You change one connection string, nothing else. Now the honest trade-offs, and they matter. With no broker, there is no central place that stores messages. If a subscriber is down when a message is published, that message is simply gone, no durable queue unless you build one. Delivery is best effort by default, and back pressure is yours to reason about. Each socket has a high water mark, how many messages may queue before ZeroMQ starts blocking or dropping. You decide what happens when it fills. You also give up what a broker hands you for free, a central point to monitor traffic, enforce routing, and see the whole system at a glance. With ZeroMQ, that visibility and control are no longer built in. So the choice is a real trade. ZeroMQ swaps a broker's durability and central control for speed, simplicity, and no single point of failure. It's perfect for fast internal fan-out and pipelines, and wrong when you need guaranteed once-only delivery. That's ZeroMQ, messaging as a library, not a server. There's no broker in the middle, peers talk directly, whole messages replace raw bytes, and pre-built patterns like request reply, pub sub, and push pull carry the real weight. Hidden machinery shown, so next time you reach for a message queue, remember there's another way, one where the intelligence lives in your own code and the network is just a string you connect. Follow how it all runs for more. See you next time.